Hi friends, hope you're all doing well. And now we're going to discuss the pandas. Okay, so this particular pandas most frequently used um, library in the entire Python orientation, no matter whether it is a generic programming or else the data science or data engineering kind of the things. So this pandas, okay, usage in Python. Let us start the discussion. So basically friends here, if I'm referencing the pandas orientation, if you remember in the NumPy, so just we have taken some kind of the examples where our entire aspects are revolving around the concept of the arrays that we have seen. Now, if I'm talking about this particular pandas, friends, um, so let me introduce which are all the aspects related to these pandas, and then we'll discuss how we can make use of these kind of the conventions. As far as this pandas is considered, so we are having two important considerations. One is the series, second is the data frames. Okay, so these two, the entire discussion related to pandas is revolving around the series and as well as the data frames. But before going to introduce what exactly the series and data frames, let me introduce what exactly the functionality of these pandas. Okay, if you observe guys, suppose if I'm talking about the NumPy, so let me introduce some kind of the data with us. So maybe I'm having some employee number, employee name, skill set of the employee, experience range. So this is the data I'm having. Maybe at some of the locations, I might not have the data. Okay, maybe if I'm taking some kind of the employee. So just if you are referencing some kind of the data, so correspondingly, suppose if some of the member skill set I'm not having. So maybe for Uma, PySpark experience I'm not having. I mean, experience was not recorded at the time of giving some consent to join, or else before the offer or something like that. Suresh skill is not there, but I could see his experience is 18 years. And Venkat is having the background of some Python and he's having experience of some 20 years. Assume that. Now with this orientation, friends, with the simple data, okay, maybe simple or any number of records also no problem. But in NumPy, we are not having any specification related to these missing values. Okay, so NumPy is missing the features of suppose I can say I can put like this: NumPy is missing features, some of the features to enable, okay, to enable data analysis on kind of see friends, one more important point, relational data. Like, see, in case of the SQL, everybody friends, maybe he is having the background of Java, might be he is having background of the data warehousing, or he might be some Hadoop or big data kind of the context. For every one of us, we are having the SQL background, maybe some kind of the commands. Okay, so basically these particular commands, which are like a table or relational format, and we always love to have those kind of the items in the specifications, like the table data and fetching of the portion of the data and all. So these kind of operations are lagging in NumPy, friends. And one more, some of other points I am getting here, some kind of the limitations of NumPy, because as we are habituated to, I mean, if you are referencing the kind of data, we are habituated to reduce the lines of code. On the similar lines, suppose I'm having some kind of the data with me, and there is like above said, so maybe instantly I want to add some location. Okay, simply there is no chance in NumPy, friend. So very first limitation is there is no direct way or no way to attach labels to the data, because at times, you know, friends, suppose maybe I'm having some data. I may be having, I need to add some more data related to the existing things. So in that particular case, to attach the labels to the data, we are not having direct approach. And second important thing, friends, no pre-build. Okay, no pre-build methods to fill missing values. Okay, so like, you know, maybe I can fill zeros or some kind of the mean values in not a number, because in Python there is one special class nan, which is not a number kind of thing, where we can treat this thing as a missing value. Okay, so in general, friends, while collecting the data, maybe the data entry operators would have overlooked that some of the data items, and they may not properly recorded those kind of the input data items. So in that particular case, some mechanism must be there so as to update the corresponding missing values. These things you can consider as a limitation. Coming to the other point, majority of the time, friends, maybe I'm having the PySpark skill, and if I want to have the same kind of the members which are there in the same skill set, maybe some of the other members also, like Santosh, or else some kind of the Lokesh might be, they are also having the same kind of the skill set. I want to group all these members into one kind of the label. Okay, so in NumPy there is no way to group the data. This is also one more important point we have to consider. And of course, in case of the NumPy, already we have seen, generally if you refer the aspect NumPy, on top of this particular NumPy, our Pandas has been built. That means we can still enjoy the numerical Python benefits in the format of the stats or whatever the means. But additional aspects, as mentioned earlier, I can have a relational look, and adding the labels with the simplest way, and pre-build methods so as to handle the missing values, and I can group the data items in a simplest way. So in a simple liner, friends, what exactly Pandas is? Pandas is built on top of NumPy. Of course, definitely in the earlier session also we have seen to make, but what for? To make data processing. So to make the data processing on some kind of the relational format or relational data much easier. We'll see, friend, that point, because you know, because if I'm claiming something, definitely as per our earlier interactions also, you would have seen we are definitely verifying the possibility. Okay, so that is how you can refer. And now let me introduce one more important thing. Pandas for data science or data engineering. Friends, there is a always the distinction is data science is a combination of data pre-processing and loading of the data and feature engineering, and then implementation of the model, again evaluation, these things. Data engineering very strict to I can say loading of the data and working with various input data items, various environments, that comes under the category of the data engineering aspect. Most of the times the data engineers are going to add some features or handle some kind of the input data and loading, performing the missing values or encoding. These are all important considerations if you are referencing the data engineering aspect. So in either case, okay, the pandas are helpful to maintain the convention of both data science and as well as the data engineering aspect. So definitely I can say these pandas for the member or the developer who is working in data science or data engineering context, pandas is very useful, is a crucial kind of the tool, I can say. And generally what we can do with the pandas, just to observe here friend, ingesting the data. And of course we have seen in NumPy also we can ingest some kind of the data. Similarly we can ingest here, storing the data somewhere in the format of data frame, and most importantly the pre-processing aspect. Here friends, pre-processing in the sense generally what we can say is the missing value imputation. Okay. And then if you are referencing the pre-processing, these are some encoding techniques, some kind of the encoding. And apart from that, we are having some kind of the feature engineering. Okay, so these things are comes under the category of the pre-processing. And moreover, friends, with the visualization also we can perform, but of course in pandas also little bit visualization of data in the format of the info and as well as the describe. Visualization may not always in the graphical format, maybe a little more explanation or maybe the exploring the data in a better way is also comes under the category of the visualization, can all be done. Okay, so all these things can be done effectively friends. Okay, effectively with pandas. Effective here meaning is suppose if I am talking about the normal thing, maybe I can perform with some other aspects also, but I am not considering any performance orientations. Simply I am making use of some kind of the constructs and all. But here if I am talking about the pandas orientation, so all these things can be observed effectively. So which are all the focus areas of today's session. Okay, so this particular session basically focusing on suppose if I'm talking about the pandas objects, can someone help me friends, which are all the objects we have seen in the pandas? One is series, okay, and second one is of course data frames. So these things are very much helpful to implement the aspects of the pandas. So in a single liner, because many things we have talked, like in a single liner, pandas can be used for data wrangling, or else I can say data cleaning, or sometimes it can be known as data munging also friends. Okay, so various aspects would be there, but the meaning or the ultimate goal, the outcome is simple. Okay, this is what how you can refer the orientation of the pandas. We have started with the pandas and what exactly the NumPy orientation, and thereafter which are all the limitations we have seen, limitations of the pandas, and then what for pandas we are using, and little bit more focus areas on pandas or series and as well as the data frames. Okay, now as usual, just let me start with the our favorite Jupyter notebook. So from that particular point, so just we are going to uh, use the various aspects like how we are implementing the pandas in the context of the series and as well as data frames. Okay, Be with me, guys. So just in the initial things, just let me creating the series. Okay. So basically, which are all the two important um, aspects we are making use, friends, in case of numpy. Okay, just import numpy as np, because we are again we are not leaving them. The advantage of this python is, whatever the earlier things, maybe that is a list tuple or set, or that might be the um, that might be, so if you are referencing either of things. Okay, so just we are piling up all those things, we are not leaving them, we are as it isly, again we are using the things in our upcoming implementations also. Okay, so just what we are doing is import numpy as np, and again we are importing pandas as pd. Okay, so just we are making use of these two libraries. Okay, so these two are very very important libraries where we can make use of implementing the numpy and pandas orientation. Now, at the moment you are talking about this NP and as well as the PD kind of the conventions. Um, so NP is a shortcut and PD is also a shortcut kind of thing, where is alias name, rather than using every time NumPy, pandas, entire things. Just you can go and make use of the shorter form NP or PD. Now, okay, this importing is done. Second thing is, friend, just as I mentioned, we are having some series declaration. Be with me, guys. PD dot series of. Just what I'm doing is just I'm making use of some. What is this actually? Yes, this is the list. So you can easily tell that, na? So just if you are, if I'm making use of any these kind of the brackets, definitely that is a list kind of thing. Now, yes, one if I'm seeing, just to spend some time here, friends, because in the earlier things we have declared some list tuple series, and recently we have worked with some kind of arrays also. So in all those kind of the cases, we are having some kind of implementations. So similarly here, if I'm referencing, you could have observed just with the PD pandas, S is capital here, friends. S is capital, and with that we are sending some list as argument to this particular series. So automatically this is going to generate a series, and which is returning into the object S1. Now, if you observe in all our earlier declarations and display of the data, we are not having this default index actually. So one of the important point in series is so this particular series provides the default index. Okay, so with the help of that particular default index, one can easily process the data. So series provides a default index along with the actual data. Okay, I'll explain, friends, what is the use of default indexing and all. We'll see in a while. Now, similarly, in the arrays also we have seen, suppose if I am declaring my series like this, so PD dot series of, again same kind of thing with the same values, something like 2, 3, 5, 8. If I'm saying so, if you observe cleanly, is a Fibonacci series actually. Fibonacci in the sense previous number plus current number is equal to next number. So 0 plus 1 1, 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8. So just like that. Okay, rather than using the normal numbers, just I thought of using the Fibonacci. Okay, just you can refer this and you can make use of this particular S2. Now automatically it is giving us the floating point kind of the data items as that of the arrays only. So how we are using that numbers, and is a kind of homogeneous pattern it is following. Now if you are referencing this S1 again, so just we are having some data and all, and it is again providing some separation, like you can clearly access the values without any index, and you can also provide the index s1 dot index. Now you spend some time here, friends. The values are nothing but the array type, and the index is nothing but which is starting from 0 and populating up to 7 with step function as 1. So that means this series is nothing but array. It's not nothing but array with index. So if you see this, we will add one more point here. Series arrays with index. That's all. Okay, see how we are moving, friends. So this particular thing is having the values, which is giving the array type and the corresponding values, and it is providing the index also. And just if you are referencing the picking up of only values rather than the kind of the representations, what you can do, friend, just you use the loop. Okay, all you are knowing now, for loop values in there are certain values now, s1 dot values, because our all values are available in the values, and just you can print off this particular v. Now you can print these kind of the notations. And similarly, if I want to get the index for index in similarly s1 dot values, s1 dot values or what, I need index only now, so that I can give this particular index, otherwise I am getting again values. And just you can print off I. Now you see only the index I am getting. So this is how you can make use of our values and as well as the index notation while working with the series. Okay, you may ask me, how do I access both the things together? Okay, so for that particular thing, one excellent function is there for us, friends. For item in, there is a zip function actually, where this particular zip function helps us to integrate the index, and you can integrate the values also. Okay, so once you perform this particular thing, and you can straight away print the item. Okay, whatever the item we are specifying. Okay, now you see just it is representing like a tuple kind of thing, 0 0 1 1, because the first one is all index 0 1 2 3 4 5 6, and second thing is our values Fibonacci like 0 1 1 2 3 5 8. Okay, so like that you can perform the activities which are revolving around the index and as well as the values. Now just observe here, friends, our old friend, this one s1 of 0 and s1 of 5, if I'm saying, obviously you can see here the corresponding index value 5 is 5, corresponding index value 0 as 0. That means how we are accessing our elements from the list, we can perform in the same way with respect to our series also. There is no differentiation. Now let me give you one more example. This time what I'm doing is I'm creating one some planet kind of the information. So just we'll be creating some kind of the series. This time I'm taking some kind of the values, friends, 0.33, some 57.9, and I'll give you what exactly the values are. And once this thing is over, just I can establish the index also. Index also in the format of the list. One is the mass. I can use capital or small, whatever. Let us use capital mass. And then I am using the diameter. Okay. And thereafter I am using the day length. Okay. Some data I am having which is related to this particular planet. Just run this. Okay. Now what you can see, friends, Mercury. Now you see the meaningful things. Okay. So the advantage of this particular series is, in the earlier thing we have not mentioned any index explicitly. Directly in this S1 or S2, just we have given some kind of the data, and accordingly the appropriate series generated automatic index. But sometimes there may be a possibility of giving our own index also. Okay, in that particular case, one can declare this particular series like this. You can specify the values. 0.33 can be relevant to the mass, 57.9 can be relevant to the diameter, and 4222.6 is related to the day length. If you remember, friends, in case of the arrays also, we have seen some example weights and heights and age. So just we're having some kind of the arrays, and what we have done is we are making use of that particular arrays together with the help of the VStack, and there we could able to perform some kind of the data pre-processing. Okay, so now what we are doing is Mercury. Now can someone help me, friends? Mercury of, if I am giving like this, okay, see, so that I could able to directly refer the index rather than the numbers. Okay, similarly, Mercury of, and I can see diameter. Okay, so it is giving some value, whatever the diameter. So this is one convention rather than always dependent on the default values. Now, if I'm asking you guys like this, Mercury of 0, let us see. Okay, that remains same. So 0, 1, 2, that remains same. And but you can also use the names, whatever explicitly you have mentioned, either with the user defined name you can give. Okay, or else you can give with the predefined, whatever the predefined aspect I am having. In either of the case it works. Now what I am doing is I am declaring one array, friends, here. There we have seen our favorite random dot random integer. Okay, here what I am specifying 0 to 10, like 10 numbers I want. Okay, now just you can refer this array 1 randomly. Integers got generated between 0 to 10, and you can easily say these are all 10 numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. All these numbers we are having. Now these numbers, whatever the numbers I'm having, so just I want to create one more series actually. So series, how to create, friends? PD dot series of, just you simply send this array. Now you observe here again the default. So 0, 1, 2, 3, 4, this is the index, and whatever the values I'm having. Okay, so random values I'm having, those things. So similarly, one more array I want to declare like this: array2 equal to, what I'm doing, np dot uh, rather than arrange, let me use the random again. I want to generate the random values and random integer of. So this time also just we are taking some values, and this is the array. And now I want to declare the index of this particular array. I mean in the series I want to use. What I am doing here is np dot arrange is there na function, and I want to generate some 10 numbers, because here I am having the 10 random integers. Correspondingly, I want to generate the integers also. Okay, 10, 11, 12, 13 up to 19. Now observe here, guys, just we're having the S4. Okay, here. What is the process? PD dot series of. Okay, na? So array2 comma. Just I am making the index. See here, second parameter index equal to ind2. Okay, that means a simple narration here. So in the earlier example, we have taken some values, and correspondingly we could able to assign the indexes. This is one development we have seen in the series. But second one is I'm directly making use of the array without any indexing, and just I want to generate this particular array into the series. I have done that. But now what I'm doing is, along with the declaration and the generation of this particular array, I want to perform some kind of the indexing also on top of that. Just you can refer these things. So hope I have executed these things. Run, run, run. Okay. So just you can refer S4. Now you see, guys, 10, 11, 12, 13, 14 up to 19. Whatever the numbers we have taken randomly, those things were mapped with the corresponding things. So likewise, you can perform the activities of the indexing and as well as all the uses of the arrays. Okay, very simple notation. Now what I'm trying to do is, maybe at this moment, is there any Python data structure is coming into your mind, friends? Just to think through. Any data structure is coming to your mind, like some here I am having some mass and as well as the 0.33. Yes, is a key value pair. Can someone help me, guys? What exactly, which kind of the data structure I can go with the key value pair in Python? Exactly. Okay, so that is what you call the dictionary. Dictionary. Let us see how a dictionary is relevant with the series. Okay, so how we can make use of the dictionary so as to use the dictionary into our series. Okay, what I'm doing is just I'm declaring this particular dictionary. Okay, so this particular dictionary, what I'm doing is just I'm making use of this thing, and what I'm doing here is, guys, same data, uh, mass, because already that the data is handy for us, na? So just I'm making use of, just to recollect in the dictionary, if the values are there, then directly that value is getting updated. If the value is not there, it is going to create. So a diameter, what is the diameter value, friends? In the example we have taken something like, yeah, 57.9. So this one I have taken, and d1 of, next is the day length, na? Day length, just you can mention that 4322.6 is a simple dictionary, nothing else. Okay, so just if you refer the d1, so correspondingly mass 0.33, diameter, what is that, guys? 57.9, day length 4322.6. Okay, perfect. Now what I want to do is I want to generate, okay, the corresponding value like this. Mercury 1 is equal to PD dot series of D1. Observe here, guys. One simple thing. Uh, Mercury 1 if I am doing, so nicely arranged data. So mass, diameter and day length, whatever I am having. So simply we are having 0.33 and all these kind of the data items we are having. So the point here is always that particular series need not be generated with the list and need not be generated with the array, or else need not be generated with some kind of the index or random, but also you can generate with the dictionary, because the dictionary also is a well organized data actually, like key value pair, na? So similarly here also the same kind of the aspect I can make use with respect to the series also. Okay, so that how you can refer the orientation of this indexing and all. Now a little trick is there, be with me, guys. So Mercury 2, what I'm doing is here PD dot series of, what I'm doing is my D1 dictionary is there. Just observe here, friends, the index value what I'm doing is um, just I'm making use of only mass and day length. Okay, let us see this, what is going to it is not written any error. That means I have picked up mass and as well as the day length. And let me print this Mercury 2. That means, friends, we have claimed that picking up of some particular entries, identification of the labels is easy in NumPy, is easy in Pandas actually. NumPy, as it is the data item, we are going to apply some numerical kind of the computing. For that, it is always better. But at the moment, I am talking about these Pandas orientation. So basically, this Pandas helps us to work with these kind of the labels in the most flexible way. Now that by this time you would have realized maybe the creation or usage of this labels with respect to the data and as well as the indexing, all these things are very much helpful. Okay, now most importantly, friends, usage of this every usage of this pandas, we are having two constructs actually. One is the ILOC and second is the LOC. Just to be mindful, friends, while using this, ILOC is nothing but uh, internal location, and this particular LOC is okay, which is user mentioned or user defined location. Maybe with some example you can have a clarity about that. Okay, let me declare one more series. How many series were okay? S4 we are having, creating a new one more new series S5. What I am doing is pd dot series of just I am making use of some kind of the numbers friends as that of Fibonacci 0 1 1 2 3 5 8. Now just observe, be with me guys. Index, what I am doing is index, what I am doing is here I am taking not from the zero, the humanly way of doing the things. So we start from one counting and all. So we are having some 7 numbers. Correspondingly, we are making use of this index starting from 1 to 7. Now, as we expected, this time we are not getting 0, 1, 2, 3 like that. But accordingly, just we have mentioned this particular index as 1, 2, 3, 4, 5, 6, 7 like that. Now, the point here is suppose if I am making use of these kind of the things, observe friends here S5 dot ILOC of 0 and S5 dot LOC of 0. Be mindful friends, be with me. So we are having user defined kind of the indexes from 1, 2, 3, 4, 5, 6, 7. So accordingly, the corresponding series is generated with respect to all those particular indexes corresponding to the values. Now, see, actually 0th index is not there if you observe. There is no 0th index according to the user defined. But internally, Python counts the appropriate information starting from the 0 only. That we have to realize by this time. See, that means though we are using the user defined or our own way of recognizing the indexing, but Python is having its own indexing mechanism. If you see, in case of this Mercury, while we define, there only I have given some hint. If you remember, Mercury of mass is nothing but the user defined. Mercury of 0 is the predefined actually internal. Okay, index based. Okay, the default. That means this mass, diameter, day length, or though these are all mentioned by the user, but Python is again having the same follow up like 0, 1 and 2. Okay, 0 is for mass, 1 is for the diameter, 2 is for the day length. With that, if you recollect this particular thing, ILOC of 0, as index always start from 0 so that it could fetch that particular value 0. But why this is error? What is the reason behind LOC is getting error? Yes, that means LOC is not the predefined. That means it is looking for the user defined. There is no user defined index 0 here. Simply it has written some error. Key error. So that what we should do. So what is the series name? S5. S5 dot LOC of. We are starting from 1. That's all. From 1 again it is normal. Okay. S5 of LOC of 1 definitely gives 0 based on the LOC value as user defined. ILOC is the predefined kind of the convention, index based location. So that is what how you can refer the usage of predefined and as well as the user defined kind of the LOC. So that means suppose you can one more thing S5 dot ILOC of 5. Okay, ILOC friends, not LOC, ILOC. So that means it start from this thing 0, 1, 2, 3, 4, 5. The value must be 5 friend because index is 5. ILOC, na? ILOC index is 5 here. Value must be 5. Let us see. I should get value 5. Yes, I got it. Whereas if I am talking about S5 dot LOC of 5. Okay, going back. And LOC of 5 means friend directly it is pointing to no counting nothing. Our Python is pointing to this user defined index, corresponding value is 3. Directly it is going to pick up that value. Value must be 3. Let us see, is 3. So this is how you can manage the orientation of your LOC and as well as the ILOC. So which is very useful constructs, friends, because these particular constructs maybe if you are interested in your predefined ILOC, you can straight away go ahead, or else if you want to maintain your convention like in the user defined way of accessing, that is the LOC. In both the ways you can implement. Now I'm having some data for you guys. I have collected some information for you. So just let me open and use the data. So here I'm having mass actually. So mass of various planets. What I'm doing is here I'm directly using rather than typing and spending much time. I'm having my data like this: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Like that, I'm having some data item and corresponding, you know, their weights. Okay, so just I'm having 0.33, 4.87, 5.97, like that, some data I'm having. Okay, so you can easily recognize from the definition, it is definitely a series. Okay, so series. Now at the moment we are talking about the mass, just we are having a nice representation because these are all user defined indexes, Mercury, Venus, Earth and all. So accordingly the values are there. Okay, it's a nice series kind of the data. Now let me know this point, friends, from you guys. Just I am making use of mass dot internal location, index based location of 0. If I am saying, what could be your answer? ILOC of 0. 0 is there now here. Predefined wise, user defined wise, no 0 is there because we are referring this particular mass series as Mercury, Venus, Earth, like that. But ILOC I'm talking about. ILOC means Python way of doing the indexing. What is the Python way of doing indexing? Here obviously it is 0. So that it is giving 0.33. Okay, that's it. Okay, and now tell me this, friends, mass dot ILOC of 3. No confusion, nothing. This is 0, 1, 2, 3. Mars, okay, 0.6420. So just it is 0.642. Now you tell me this, guys, mass dot LOC of Pluto. That means LOC means our user defined. Directly I can refer now with the LOC. If I am giving ILOC, definitely it returns some error because index default index is generated by Python. Okay, just I am giving the LOC. We are making use of this thing and corresponding value I am going to get. Okay, that's it, friends. Okay, that is how you can refer the orientation of the usage of this kind of thing. Now, if you remember, friends, one simple aspect in the arrays latest while closing that NumPy working, there we worked out some cricket example. There we have loaded some data and there some runs scored by Sachin, Rahul, and our Indian team. And that is there. On the same lines of the ground, let me apply this mass greater than 100. Similar to that. So what it is giving, friends, whenever the condition is satisfied, there we are getting the true. That means for Jupiter it is true, for Saturn it is true, for Neptune also it is true. For remaining all, the mass is not greater than 100, so it is generating the false numbers. But whereas if you want to get the numbers, very simple, mass of the same kind of the equation you can represent here. Okay, so the values. So if someone asks you to list out the planets who are all giving having mass as greater than 100, just you can make use of this kind of thing because it is a twofold. One is applying the condition and getting the values. Okay, whenever the value is true, then only it is going to output the values. And there one more important thing, friends. So suppose sometimes there are some situations where you can apply multiple conditions. So in that case, let us have a look on this. My first condition is mass greater than 100, and my second condition is, friends, mass less than 600. Sometimes, I want the people who are having greater than 10 years experience and but less than 15 years of experience, maybe some architect roles or something like that. So it is always good programming practice, friends, while doing these kind of the things, just you place these things in the brackets actually. Okay, these brackets, and along with that, in Python we are having this end as ampersand, and so the readability is very simple now compared with the earlier thing. So one can easily, anybody can come and see that, oh, this mass is greater than 100, and symbol he is using, that means both the conditions should satisfy. The second condition is, of course, mass value less than 600. Now what we can do, friends, here I am doing this mass off. Okay, so just you can refer this. Any guess, guys? Here it should be greater than 100 and it should be less than 600. And of course, we got some subset from the main mass data. And out of this also, again, we are applying one more condition. That condition is our mass should be less than 600. So you can easily expect, because Jupiter is greater than 600, so it won't come into this particular condition. Okay, so observe here, we will be getting only Saturn and as well as the Neptune. So this is how you can refer the multi-condition aspect with respect to your pandas. Okay, especially the series. Now maybe at this moment you can have some kind of the doubt also, friends. Okay, NumPy, on top of NumPy, we have designed some kind of the pandas, and the reference is that, okay, many things we have seen, but one of the important aspect is you can easily realize that arrays are definitely from the NumPy. There we could use this arrays directly in the generation of the series. List also we have used here, the arrays we have used, and then we have used some kind of a random integer. This is also from NumPy only, na integrations, all these things. So random integer and all. Now what you can do is we can apply some kind of the mean, all those kind of the things also, friends. Very simple. Let us see this mass data we are having, and what we are doing is NumPy dot mean. However, I want to find out the mean of all these planets, and which is having the minimum mass. Okay, so I want to get that Pluto, obviously, and I want to get the bigger one. Just now we have seen a bigger one, this one, Jupiter. Okay, so np dot a max of mass, the Jupiter one. Okay, so like that you can easily apply some kind of the conventions while using these pandas way of doing. Okay, now one more important thing, friends. We are playing with index, and we know that suppose if I am performing this kind of the orientations, addition of mass plus mass, which is with the broadcasting, all the things are there, and mass minus mass, obviously we are getting the 0. Okay, these things, no matter whether that is the array or series, the broadcasting remains same. Index observation, so both corresponding index would be there, and they are going to maintain the convention. What I'm doing is I want to store one kind of the index like this, friends. I want to apply some kind of the operations of the mass. High mass, the planets which are having high mass, I want to segregate that. What is the thing, friends? Mass value greater than 100. So my H mass is, sorry, H mass is containing these things. This is pretty no. And one more thing, what I'm doing is I want to generate a new mass with existing mass plus high mass. That means we have generated high mass. And what I want to clarify here is if you see mass, all planets are there in the mass. But if you see H mass, we are having only 3 planets. Let us see how Python Pandas handles this. Okay, so n mass. Just be mindful, friends, here what exactly it is doing. Yes. Okay, that means mass is having all the data. H mass is only having only those three planets. Now you can realize only the planets exist in both the series. They could able to come up with the answer, and for all the remaining things, Pandas has fixed that not a number kind of thing. So this is one more point where you can observe so as to work out the missing value kind of the things. Okay. Now, as we're talking about the missing values, now you see here PD dot. There is a construct called is null, and our new mass is there. Na? Just we are sending that. That means, friends, here, if it is true means yes, that value is not there. Okay, if it is true means that value is not there. If it is not true means the value is there. So that's what is null. Okay, it is returning true. That means the value is null here. Jupiter is having the value so that it returns false. Neptune is also having the value so that it is returning false. But Pluto also having the value, no? So just it is returning true. It's not having value so that it is returning true. But Saturn is having the value 1136. Okay, that is what. So whenever the null value is there, it is returning true. Whenever the value is there, it is returning false. Okay, like that you can specify. So now a very simple thing. Okay. So suppose if I'm making use of the mass again, and I want to add a particular data. Okay, so I want to add moon also here, uh, like this with certain kind of the mass, maybe randomly I'm giving. So uh, like, and if I am making use of mass, you can easily see this moon also added. Is that much simple, friends. Okay, so simply I can add one more label, moon. I can assign some kind of the values, mass of moon. Okay, like that you can easily mention or play with the corresponding data. And now sometimes, you know, if I want to perform the dropping, so just observe here, drop off. Just I am yeah, Pluto I want to drop. Okay, so just you can see here directly I can able to see the things which are there already, those things only I can specify. Okay, this is how you are referencing, how you can make use of the convention, like making use of, okay, the appropriate pandas, especially the series kind of the thing, which are very pretty easy, friends, and you can straight away make use of the conventions. Okay, right. So now just have a break now. So just before that, we are having the concept of the data frame. Okay, so just let me do one thing. 1 minute, guys. Okay, right. So hope you have had a break. So now let us start with the data frame. Our general way of convention, first we'll do the things and then we'll verify what exactly the that construct is trying to say. Okay, here let me start with the array, because we let us start with the known things, and our favorite random integer, so as to generate, observe here, friends, what it refers, 5 3 5 rows, so 3 columns. Now you see 5 rows, 1 2 3 4 5, 3 columns, column 1, column 2, column 3. Okay, so now what we're doing is just let me take one convention, df pd dot, observe, guys, data frame. Okay, simple. How we are declaring our series and all, similarly we are taking the data frame also. Have a look on this, guys. This is our entire life of data scientist and data engineering. Data engineer's life is revolving around this data frame. Okay, so which is having some kind of the input data, and it is providing some information in the format of the rows and columns in a nicely arranged way. And did we mention any index, friends, by default? If you see here, did we? We have not. Na? So just we have given the numbers, and we want to generate the values. That's all. But whereas if you are referencing this particular data frame, it is nicely created that row 0, 1, 2, 3, 4 like that, and the column 0, 1, 2 like that. Okay, that is a default index. Now similarly, let me give you some kind of the summary. Values only, it is giving the values, and as you expected exactly, we can have the index also 0 to 5. 0 to 5 obviously related to the your rows. Okay, now if I want to get the column indexing, I'm having 0 to 3. So index here reference to the rows, friend, just to remember this point, refers to rows. Okay, columns, obviously columns refers to columns only. Now as mentioned in the earlier thing, we are having the values also now. So df1 dot values of, just you, if I am talking about the 0, can someone help me, friends, what it does? Simple. Okay, 0th record, actually 614 0th record, first record, like that. So values always pointed by the record orientation. Maybe you are having some doubt. Why should I go with the default index? Because as that of the series, is there any possibility of making use of my data frame with the user defined indexes and as well as the columns? Again, I am referring, friends, in case of the index, it is a row. If I am talking about the column, it is by default column. Okay, rows were referred by the index. Now what we are doing is df1 dot index. Just I am specifying a list like this, friends. R1, row 1, row 2, row 3. Again, I am having row 4, row 5. Okay, so I have created the index. So df1, if I am saying my index is R1, R2, R3, R4, R5. What can I do, friends? Next thing, df1 dot columns of, columns equal to, actually just this time I am making use of the column 1, column 2, column 3. Okay, so just you can run this, and now you see, friends, nice arrangement of your data frame. So whatever the rows I want to give, R1, R2, R3, I can give. C1, C2, C3, I can able to give in the columns. Now the same point. Yeah, you are right. I can use LOC and ILOC. Now let me go through this. If I'm saying R3 and as well as C3 like this. Okay, now yeah, you are right. LOC is not the predefined one, user defined one. That means it goes to R3 directly. But you asked Python to pick up only C3. That means 6. Okay, so just you can refer this thing. Now tell me, guys, this thing. ILOC of 2 comma 2. 2 comma 2, friends. I have not given the number. I have not given the row 1 C1 like that. I have given directly the numbers. As you expected, first thing always refers to the rows. Maybe that is the array, series, whatever. The first thing, first subscript always refers to the rows. It goes to the second row. Second row index based 0, 1, 2. That means R3. And it is going to fetch a column. This is 0th column, first column and second. It should give 6. Let us see that. Simple. Okay, so this is how you can refer the usage of your LOC, ILOC, and what all the kind of the notations. Okay, and further, if I am making use of this thing, ILOC of 2:4, comma 1:3. Don't be in a hurry, friends. Just you observe here. I want to pick up indexed based locations of Python, and I am giving 2:4. 2:4. That means it is going to start from 0, 1, 2. It should go up to 4. But 4 is excluded na, in case of Python. So it is going with 2 and 3, these two rows. But again, we are specifying one more slicing. That is, I have to start with the first column and I should end with the third column. That means my first column here is C2 and second column here is C3, but no third column. But why I have mentioned this third column is up to 2 I want. That means first column and second column I want. That means 3, 6, 1, 8. Up to this particular portion I should get. Okay, because many rows, those many rows and those many columns I want to get. So 3, 6, 1, 8. So similarly, if I want to perform like this, df1 dot loc of, be cautious friends, loc means your way, r1. I thought of giving this thing to you because there is a little trick here. C2, C3. So just observe guys here, because it is very, we should be very cautious while using the user defined way of mentioning the rows and columns. And in index based kind of thing, we are very clear that the base value, the base index is included and the upper index is excluded. That means 2, 4, it is taking 2, 3, 1, 3, it is taking 1, 2. It is not going to 3. But here a little trick is there, R1, R3, C2, C3. Okay, first let us run this. Oh, we can see R1, R2, R3 also. That means the upper index, whatever you are mentioning with LOC is not excluded. That point we have to underline. Next thing is C2. Of course, it is starting with C2, but it is not excluding C3. It is including C3 also. So one important point we have to observe here. Let me record that. So in case of LOC usage, both lower and upper subscripts were included. Okay, but in case of ILOC, that is the default thing, na? ILOC, however, I will write down, no problem. Okay, later point of time you can prepare. In case of ILOC, lower subscript is included and upper subscript is not included. That we know, na? Okay, so AB, if I am saying, that means suppose observe here, df1 dot ILOC of A colon B, comma 1 colon 3, for example, friends, because first one is the row, na? So A includes -1 includes, not B, and 1 includes in the column, T minus 1 includes. I like that you remember in case of the ILOC. So there is a little distinction in LOC, both includes, maybe the lower subscript and upper subscript, but in ILOC, that same point in case of the arrays or list or whatever, the same thing you can observe. Okay, that is the difference between LOC and ILOC. Okay, so and one more important aspect I want to clarify, because we have not defined data frame yet. What I'm doing here, guys, let me copy this one Okay, let me copy this one. And I want to find out the type. Long back we have seen this function actually. If someone could refer, that would be great, which is used to find out the type of the data. Okay, definitely that is a data frame. Now what I'm doing is a df1 dot ILOC of 0. First row, na, however 0 means first row. This is giving the first row. Suppose if I want to specify the type of this particular thing, a portion of the data frame, assume that. See friends, here something is coming to your mind. Yes. That means the series here, it is nothing but a series. Now see here data frame. So some 5 rows and 3 columns, and just to remember friends, what is the shape of this data frame by the way? 5 by 3, 5 rows and 3 columns. There we have seen. Now there is a simple option df1 dot transpose actually. Maybe rows, columns, columns, rows. Like this you can easily specify. Okay, so this is how you can observe the orientation of this data frame. So you can observe the data frame. Okay, so data frame is the combination of multiple series. Okay, so that is the a simple background where you can refer. Series is nothing but the index with array. I mean array with index, whereas data frame is nothing but our data frame is nothing but a combination of series, integration of series. Okay, right. Coming to the other option, because other things are also there where you can refer. Just I'm having this mass, and we have done some modifications now. So what I'm doing here is again I'm going back to my original data, and I want to generate this particular mass once more so as to work with that mass again. Okay, now I am having this mass again with me. Okay, the same source. Okay, whatever I'm having. What we are doing is again I'm having second list of data, that is the diameter. If you observe this particular diameter friends, so diameter of Mercury, Venus, Earth, all these things. So let me pick up that thing also, so that I want to showcase some of the functionalities to work. Here is the diameter. Now, okay, so we are having mass and as well as the diameter of these kind of the planets. Now a simple thing we are following here. Already data frame 1 is there with us, and data frame 2 we are creating. How to create the data frame friends? PD dot data frame of very simple thing. Now I am having mass with me with Mercury, all these things, diameter also there. Now observe here friends, if I'm using these kind of the bracket, definitely it is a dictionary. Okay, so mass key and corresponding value. Okay, so and then diameter corresponding value, right? So this means just I am making use of some mass and as well as the diameter, as these two are representing a kind of key value pairs. But explicitly I want to mention that. Let us see what it is going to refer. Okay, now if I am referencing data frame 2, you can easily observe now. Okay, nice, how nice it is. Earlier this mass and diameter are there. Let me check the type of this mass, which is definitely interesting to you guys. Oh, series type of diameter. Now you see, now what we have generated actually df2. Now if I am asking type of df2, yes, as we expected it is data frame. That means after integration of this mass and as well as the diameter, both are series. What is our definition of the data frame? Simple, the combination or integration of multiple series is nothing but the data frame. But I suggest you to focus on this particular declaration. What happened here? Just spend some time. Yeah, friends. Hope you have done the some kind of the observation. So the here the observation is very simple. Like what we're doing here, this is our index user defined. This also user defined. You can see here mass and diameter. So if I'm changing this particular index, no problem. That is user defined now. We can. So that obviously your mass and diameter are nicely arranged as the index of Earth, Jupiter, and all these kind of the things. Okay, like that we're having the data. So individually mass is comes under the category of the series and diameter also. But at the moment you integrate those things, it is representing as a data frame. At that point you can easily observe. Okay. Uh, After getting these kind of the conventions, friends, now what is our idea is, so suppose if I want to access my data like this, so I'm having data frame 2. Now just to be cautious guys, what I'm doing here is data frame 2 of I'm having this mass now with me. I'm giving this mass of, I need to specify, I want to get this mass of moon. Is not there now. Okay, leave it, or else you can say some Pluto. Pluto. Okay. Yes, it is working. That means individually I'm having the mass along with the Pluto. This thing. This is also one kind of LOC. Okay, na? Rather than LOC you can do, or else directly with the help of the convention, like whatever the values we are having directly you can use, or else you can use the ILOC also, no problem. The same thing, friends. Now what we are doing is suppose if I want to add a column, because that is how you can refer the working of the data frames and as well as the pandas. Because as far as if you consider this data frame 2, I can easily add the column very simply. Okay, so to add a column. So let us add a column, friends, here to the data frame. Very simple, data frame 2 of, just for the observation, new column. What I'm doing here is just I'm giving some value. Okay, so df2. See, automatically this I can able to refer this particular new column. That much simple, friends. Just I'm taking the data frame name and we are specifying the name of this particular column. That is one thing. And second important thing is within the column, if I want to add some value, suppose here earth is there and I want to add some value to that. Okay, just like this, df2 of, we are having this new column and I want to point to earth actually, earth, and I want to give some value here, maybe some huge number. Okay, so now you see df2. Okay, right. So that means whatever the value I want to assign, so directly I can able to assign. Don't worry about this warning because it is saying directly you are copying a slice. It is setting up some maybe your data frame is copyrighted or something. Okay, like Pandas is that much cautious, guys. Similarly, df2 dot, if I am making use of LOC, LOC is purely related to our user defined, na? So I can get that whatever the mass, diameter and the new column I am having. Similarly, df2 dot LOC of entire mass I want to get rather than a single entry. Can I? Okay, so the problem here is it is saying some error, friend. So mass wise it is not picking up. Okay, so that means this particular LOC is not identifying that particular mass kind of thing. What it is saying, key error, mass of something I have to give directly I cannot. Okay, so mass of Earth or mass of some Neptune, mass of Pluto likewise. So far we have worked with the column, but I want to work with rows to add a row. Okay, to add a new row actually. Suppose I want to perform some kind of the row addition. So just one simple thing, friends. In the column addition, you can easily observe the df of something. New column, but whereas in the row addition I need to depend on this LOC, friends. Okay, because simply I'm adding a user defined kind of thing, LOC of what I want to do is, friends, here I want to perform some new row I want to add. Okay, so just you can use this particular new row which there I am not having any values at this moment, and just observe here. There is a distinction, friends. Actually, new column in the sense just we are adding a column after this mass and diameter, but row is no last. Okay, along with all these planets, but this row is resembling mass, diameter, and new column because it is having other support of those columns also. Okay, this is how you can refer the usage of this adding a new column and adding a new row. And similarly, friends, I can apply some kind of the operation mean of data frame 2 of some kind of the mass, only mass if I want to perform. Okay, so just I can perform the mass of all the whatever the planets I'm having, I want to apply the mean. Now, if I want to drop there, because always there is a other side, na, drop the row actually. Now, how to drop that? Very simple, guys. Df2 dot drop off. What is the name actually? New row. Okay, just now we have created. Okay, so that nothing is there. And similarly, I want to drop the column. Okay, df2 dot same convention. New column. Definitely it returns some error. Reason, intention I have given that new column is not found in the access. Access mean, friends, in the while declaring or while working with the arrays also we have seen two things. One is access equal to 0, another is access equal to 1. Remember, guys, while working with the column, it's not only the column, it is having many rows actually with it. So for that particular purpose, be cautious. Okay, what you can do is df2 dot drop off new column. Okay, and access equal to just you are referring 1. Okay, na? Obviously you can see now the mass and diameter, whatever the values I'm having. Now you can recognize this, guys. Again, this new row you can see here, though we are dropping that. Reason is we have dropped that, but we have not permanently dropped that. We have not permanently dropped that. Okay, so to do so, okay, to drop the rows permanently, rows or columns, you can follow this convention df2 dot drop off new row. One phase is there, friends, in place equal to, within that place equal to true. Now you see, okay, no row. And similarly new column, let me do that df2 dot drop off, new column, okay, new column, and then axis must be 1, axis equal to 1, that remains same. Along with that, in place, remember friends, it is permanent deletion, true, df2. Okay, so that means either row or column if I want to drop, I just use the phrase, okay, whatever the parameter I'm having in the drop, use the parameter in drop as in place equal to true. Okay, so this is how you can mention the usage of data frame with respect to addition of a column and all these kind of the things. Okay, now moving ahead friends. Okay, so just now I'm having my original data frame with me, whatever the data frame I'm having. This time what I want to do is suppose if I want to describe or if I want to have some kind of the information. So see here df2 dot info. What it's giving is it is saying that some kind of the numbers, how many columns I'm having. I'm having 10 entries, and those particular 10 entries, one is okay, all 9 are non-null, and in diameter all are null. Non-null means which are not null, and except this moon, you know, this particular moon mass is not there friends, somehow we missed that, so that it is saying that one is null actually, and remaining in diameter there is no such case of missing values, so it is saying all tens. Okay, this is one thing. Info means it is giving us the type of the data frame and how many entries were there, and how many out of those entries the columns along with which are all the columns, and how many non-nulls are there. This much you can get the data from the info. And one more option is there friends, actually df2.describe. Have a look on this. In the earlier case we have applied maximum minimum in the arrays. If you are remember and recollect, while working with the arrays we are able to observe, okay, some kind of mean or median or those kind of the thing. But simply friends, in case of the data frames, I can able to directly apply. Okay, so whatever the information I'm having, I want to describe like what is the count and mean, standard deviation, minimum, maximum, percentile values. So just like that we can perform some kind of the data without any problem. So this is how you can refer the data frames. Okay, see friends how simple it is. Okay, now what we're doing is a loading of the data. Okay, so most important aspect in case of this data frame usage is loading of the data. Now what we'll do is at later point of time we can load our whatever the data we are having, but this time what I'm doing is we want to load some data from the predefined orientation. Okay, so for that particular thing, let me open this particular notebook. Seaborn data set is there friends, actually, which is a planet data set. So far we are using that planet data na. So just let me shoot this particular thing. What we are doing is let me see this. So the what you can observe here is the seaborn data is having some default data set. Okay, so just to click on this, I'll share this link also with you guys, or else you can simply type this cburn load data set. Okay, cburn load data set, and yeah, you select this py data cburn dot load data set, and here there is a location actually. Click on that. Okay, same either. Now from this I want to get the this planets data friends. Actually see, this particular location is providing all the newly arrived data set information. Okay, whichever periodically the because many members were adding their own kind of the things to the data set thing. Out of those things we're having the planets data. So this particular planets data set, if you refer, it is providing some information like serial number and method of finding out of that particular planet, and number and orbital period, mass, distance and year. Okay, all these kind of things you can observe. Okay, in case of the planets like that, I'm having some kind of the data. Now what I want to do is I want to load this data. I don't want to download this data, friend, because it is a default one, and I could able to uh, get this particular data directly because predefined one. Na? So for that, however, I'm mentioning this particular path also here, so that later point of time you can go and study that particular seaborne data. Now what I'm doing is, as I want to pick up the data from a particular library, na, I have to mention that library. So what I'm doing is import Seaborn as SNS. Seaborn, next we'll discuss, guys, like Matplotlib and Seaborn libraries. But before that, I want to give a glimpse of that particular Seaborn. Okay, and we are importing SNS. If you see somewhere, it is definitely belongs to the Seaborn. That is like NP, PD, how we are doing. Now we are doing the SNS also. Now I'm taking this planets data, friends. Okay, the planets data. How I am doing this thing? See, SNS dot load data set, automatically it is taking, and I am mentioning planets, that is only, no, spelling PLANETS, or yeah, like that only they have, because the same uppercase, lowercase, or whatever the way they have used. Okay, like that only we should use, then only it is going to load. Okay, because it is not our data, it is already there in the SNS. Okay, just you load this. See, simply snet.load dataset, automatically it has been loaded. Now df underscore planets, because the way how we are storing the data is that much pretty simple. It is having some kind of the information. So how it is showing, many records were there, but it is in a concise way it has shown to us like 1035 rows and 6 columns. So that means our df underscore planets. Okay, so just you can refer two things are there, na, info and describe. Info, what it is saying, friends, we are having this is a data frame basically, and it is providing 1035 entries, and we are having 6 columns: method, number, orbital period, mass, distance, year. And out of those things, some of the entries were null also. Okay, some are non-null, and those kind of the description you can see here. Similarly, df describe, if I am saying as we expected, it is giving us all the count, mean, standard deviation, mean, minimum, maximum, percentile, all these things. But if you observe, actually in our data set we are having 6 columns, but it is giving only 5 columns. Can someone help me, friends, why it is so? Just to think through. Correct. Okay, so here method is not there, friend, because this method, which is some string kind of the data, we cannot apply mean or maximum for the string, na? So because these are all the text information or characters. Other than that, if I am applying my describe on the numerical data, I could able to see the count, maximum, mean values, all those kind of the conventions. Okay, so likewise you can perform some kind of the activities. Sometimes I want to only pick up the head, only first 5 rows kind of thing. I can do that. Along with that, if I want to specify uh, some 20 rows like that, customization of those things, I can do that also. And similarly, friends, we are having tail, which is giving the last 5 rows, and accordingly you can fix up tail of some 13 or whatever you want. Okay, so all these things are possible with respect to the data frame also. So that is how you can refer the usage of the data frame orientation, and based on that particular convention, one can easily refer the observation of these data frames. Okay, now coming to the planets data, friends. there are certain null values we're having now. So just if you observe df underscore planets, okay, dot is null, there is some clause with us. So is null, if I am saying, just it is simply giving whatever the null values I am having, all those kind of the things. Now there is one more option called just if I am having the planets is na, that means is null, and any, okay, any x equal to 1, where whether it is null or not null, whatever, any. Now you see here, just as that of as a Python way of doing, whichever the things are not null, just it is giving false, and which are all the things null, it is giving true. In the earlier example also we have seen the same thing in the computing of the mass, higher mass, and all those things. If any value is there, it is giving the false, and if a value is not there, it is giving true. The same kind of the convention. So like that you can perform the kind of representation. And simply friends, one more aspect, suppose if I'm working with the missing values and I want to perform some kind of the missing value dropping, because that missing value handling is a separate topic, we'll see in the pre-processing. But in case of pandas, if you instantly want to perform some kind of the missing value dropping, okay, so there is a simple notation, df underscore plan is dot drop, okay, drop nulls, okay, drop nulls kind of things, just to refer here. Okay, now you see all the missing values, whatever the missing values are there in our data, all these things are got eliminated. So but again, the same important point, because it's not a permanent thing, it is a temporary kind of thing. Permanent means correct. Okay, if we want to perform the dropping of missing values permanently, in place equal to true, that's all. Okay, in place equal to true, and based on that particular convention, one can easily refer how we are going to perform the aspects of this missing value and all those kind of the conventions. Okay, so this is how you can refer the working way of mentioning the things. Now one more thing, suppose if I am talking about df underscore planets, we're having certain information with us. There are common points, friends. Maybe methodology is radial velocity for some of the planets, and for some of the planets, the methodology is the transit. Okay. Now, what I'm doing is I want to actually in the beginning of the session also we have seen pandas is very flexible to apply some of the conditions. Okay. What we are doing here is observe here, friends. df2 dot info. Uh, Sorry, not df2, here this is planets na? Dot info. Okay, now we are having this information with us. Now what we are doing is uh, based on the method. Okay, so because there are various methods, friends, actually, so maybe radial velocity, transit, like the different methods are there. I want to combine all those methods. Okay, so what we're doing is, be with me guys, dot in the SQL way we are having some group by option, whereas to combine all the things here, what is our thing, actually that is the method. I want to specify the method and how many methods are there, I want to find out the method. So in the planets group, maybe I'm having 10 or 20 or different methods would be there. Now I want to get that particular count, in fact, count of these particular methods according to the group of that thing. Now you can easily say, okay, so I'm having astrometry number 2 and orbital period as 2, like that we are having some different. So based on the method, we are having the count of those things. Okay, but here a little bit, with a little bit change, I can get the clarity, like planets. Again, I'm using the group by option. Same method I'm using. Okay, on top of that method, what we are doing here is, friend, a little modification method. Okay, I am fetching that method and now I am counting. See how simple. Clarity, na? Because in the earlier thing, we have not mentioned the Same thing friends, in the condition, okay, while mentioning the condition there, along with the data frame, if you are mentioning the condition, you will be getting the clarity. But here I have not mentioned any data frame, any kind of the column information, any method information, so that it is giving some values. But whereas if you want to get some kind of the clarity, so method, okay, astrometry 2, eclipse timing variation, 9 planets were there, imaging 38 planets method, micro lensing 23 planets, okay, and most importantly your radial velocity. Based on this method, many planets are there. And next to that we are having the transit, we are having the 397. So the group by option here provides how we are going to pick up the appropriate grouping, how we are going to apply the grouping in the simplest way. Similar to that, okay, suppose I want to get the distance and as well as the mean of that particular thing. So here in the planets data, we are having this distance also, and I want to find out the mean distance of those kind of the planets. Okay, think through friends. Simple. So just let me planets. Same thing. Group by we're applying on top of the method, but this time the condition is on the distance actually, not on the method. Distance, and I want to find out the mean. That's all. Okay, all my other operations, the statistical implementations, all these things are perfectly holds good in case of the data frame also. Okay, so just you can run this and simply it is giving a nice table like the method and astrometry and whatever the imaging, the distance based on that particular method. You can keep on changing the appropriate parameter according to your requirement. So these are all the conventions where you can observe the implementation of the data frame. Of course, definitely you need to practice these things, friends. And let me give the conclusion remarks. Okay, so we started with the discussion of the series actually. So in this particular session, let me give the key outcomes of the session. So very first important thing, just we have seen the NumPy limitations, because their adding of the column, adding of the row is not that much simple. So those kind of the limitations we have seen. Now in Pandas, okay, so just we have seen some kind of the benefits over the NumPy, okay, theoretically only. And we started our discussion related to the pandas. We're having two objects, one is series and second is the data frame. Now these two are the tools where you can prove the benefits are really okay. Coming to the fourth one, uh, along with this particular pandas, first we have started our discussion with the series. There we have seen that series are nothing but arrays with the index, arrays with the index. So we're having certain advantages so the series with the arrays we have seen, and with the random numbers also we have created some kind of the random int. Okay, so like that we have created the series and we have applied some kind of the operations on top of the series. And coming to the next one, we have jumped into the discussion of the data frames, which are again combination of series, friends, actually. And within this particular series, okay, so initially data frame creation, so with some arrays, and thereafter df creation with some random integer, that thing we have seen. And then we have created our data frame with dictionary, and thereafter we have seen data frame creation with multiple series. Okay, these things we have seen. And thereafter, friends, The next aspect is working with LOC and ILOC, where our LOC is user defined way of accessing the index, and our ILOC is Python way or index based. Okay, default index based kind of the access. Those things we have seen. And thereafter, guys, the data frame, uh, add or drop a column, add or drop a row. These things we have seen. And then to after this, to permanently drop a row or to permanently add a row, vice versa. So just we are having in place equal to true to affect that particular thing permanently. And then we loaded our data, loaded the data. That is the default data, friends. Actually, the planets data we are having, and we have taken the help of the Cburn, and there I have pasted the link in the notebook, friends. Okay, and from this notebook you can verify that particular link, and we could able to load that particular data. Okay, and after loading, okay, after loading again some applicability of the operations. Okay, so this is how you can observe. Okay, prepare. So definitely this data frame is not that much tough, friends, which is very simple, and you can straight away run the things and all. Okay, that's all, guys. Okay, thank you. 1 minute.